an example we didn't get to yesterday. Yes, 5-2 is supposed to be due today, and I have the answers ready for us to check, but I want to make sure we were good. Because other things showed up in section 5-2. A lot showed up. NVT showed up. Antiderivatives showed up. Graph of derivatives showed up. So if you have a given graph, let me give you a few points to mark. Mark the point -2, 0. -2, 0. Mark the point 1, 0. And mark the point 4, 0. Go ahead and do a swoop, bounce through, come back up to 4. Swoop down, goes concave up with a minimum at -2, concave down with a maximum about 0, 1, a 0 at 1, 0, a minimum about 3, -2, and a 0 at 4, 0. For those that are a little bit visually impaired, you were taking a picture. Right? Okay. They're in their notes, not workspace. For those of you visually impaired, those who are not visually impaired, who is this the graph of?
The derivative.
The derivative, F prime. That wasn't a shot at anyone.
I'm getting my eyes checked. I'm going to get my checked.
Question, when is F increasing?
-4 to 1 to -4 to 1.
-4 to, yeah, I would say negative infinity. This does not seem like endpoint. Oh, the pause. What do they give us though? A closed interval. So we're going to use that closed interval. So even though the idea of negative infinity is good, I would also say -4 to +1. What would your rationale be if you had to give it? It says justify each answer. Good. Since f prime of x is greater than 0 on that interval, right? Now pause. What should I change? Why the 1 but not the -4?
Because the -4 is on a closed interval. 1 and 0. We have that exact point.
At -4, the rate is positive. So I can say at -4, my function is increasing. But why can't I say it's increasing at 1?
Because 1 equals, at 1 is 0.
It's 0. It's an in-between. Now some people would say you should split up at -2. Technically, in my experience, this is one of those cases where we could say it's strictly monotonic. Therefore, you can say it's increasing for the whole interval. If you split it up at -2, you would probably be okay. We'll keep an eye open if we have any AP questions, like comments to how they graded it. No.
Is there a symbol for interval? Animal?
No, interval. No, not that I can think of. Like, there's like the all values of x such that x is within, you would write the interval. Like, you could use set builder notation if you want to be super snazzy, but that doesn't help with just saying the word interval.
Yeah, I was wondering if you were talking about writing.
No. Those answers. You can say for those values, but no.
That's long.
Kiddos. Yeah, it just makes it longer. Who has an answer to B ready? Raise your hand. Raise your hand. I just want to see. Okay, hold on. Give everybody another like 30 seconds.
Yeah.
Who has an answer ready now? Okay, a few more. Alan, what do you got?
I put from -4 to 0.
Not to 0. Not to 0. When is F concave up? Let's see another one. Who else? Gabby, what do you think?
1 to 4.
1 to 4?
Oh,
Nope.
What are the people that have in front of
Let me see hands. Brendan.
Is it -2 to 0? Yeah, it's 3
Yes.
to 4. It's 3 to 4.
But there's also another interval. Or you said what?
3 to 4.
Okay, now pause. Hold on. We have 3 more again. Hold on. So from -2 to 0 and from 3 to 4, it's all based on the since or the because or the justification. Who can give the justification as to why? Lucy.
This flips the F prime or
Good. You could technically probably get away with just saying F double prime, and they'll know that you knew what you were talking about by the correct intervals. But you could also say just the slopes of F prime. Does anybody have another statement they could have made besides F prime being greater than 0 or slopes of F prime being greater than 0? There is one other way of saying that.
Increase.
Who?
F prime.
F prime is increasing on that interval. All three of those are valid. F double prime is greater than 0, which is seen by the slopes being greater than 0, aka positive, which is also seen by F prime increasing. All three of those are synonymous. Good job. Number C, letter C. Either way, I know.
Close enough.
I'm moving down here. Okay, for C. At what x coordinates does F have local or relative extremity? Jonathan.
1.
1. Oh, 1.
You can tell me what it is? What is it?
Because F prime is positive and negative, either
It's a
side.
match.
It changes size.
Sorry, F prime, what was it, 1? Now, technically, if they just said local extrema, I guess since they don't say identify, you could just say has a relative extrema since F prime changes signs and F prime are 1 and 0. But let's go ahead and say they wanted you to state which kind of local extrema, and in which case it would be a relative max. And we wouldn't just say changes signs, we would say changes from good, positive to negative at that 0. Does that make sense, guys? Or
Both 4 and negative 4.
well, negative 4 isn't a critical number because we're cutting it off and it seems like there's a point at negative 4, so it's not a 0 or a DNE of the derivative.
What is supposed to be max or min?
Of the derivative, it would be a max. But we're looking for extrema of F, not of F prime. Does that make sense? For 4, it is a 0, like it is a horizontal tangent, and the derivative is negative, so the function does decrease to that point, but since it never increases after, then we can't say it's a local, like on both sides extrema. Yeah. But it would be a candidate for testing for absolute extrema, sure. Letter D. Why is there not a relative extrema negative 2, even though it's a 0 of the derivative, a critical number?
This is positive.
Good, you guys got it. No sign change. Letter D, what are the x coordinates? And then this is even if kiddos, in general, like if you're tutoring AB kids, get C right, which is hard for them to get right, and to orient their thinking. They get D wrong. So who's got it? Kyle, go ahead.
I say negative 2, 0, and 3.
Negative 2, 0, and 3.
Yeah.
Just to give you both a shot. Noah, what's the justification?
Because the slopes of that prime changes from increasing to decreasing to decreasing to decreasing.
Half right, half wrong. And how you said it. It was all when you said it. Slopes don't change from increasing to decreasing. The slopes will change. F prime changes from increasing to decreasing, which would be the same, which would be synonymous. So either F prime changes from increasing to decreasing and vice versa at those points, or the slopes of F prime change signs. Does that make sense? That's okay. Well, actually, I love that you said that though, because even though you might not have written that down, others on so many FRQs start using positive and negative and increasing and decreasing as synonymous, and they're not. One talks about the values of what you're referring to. The other one talks about the values of the derivative of what you're referring to. So they're very different things. So you could have said the signs of F double prime change at those points. You could have said the slopes of F prime, which are F double prime values, change signs at those points. Or you could have said F prime changes from decreasing to increasing and vice versa at those points. So relative extrema of the derivative are points of inflection of the original, right? Cool. Last but not least, how would you sketch a possible graph, given all that we know?
Increasing, level up, increasing.
Okay, so we could say increasing, level off, increasing,
Sign change.
okay, sign change of what?
To decreasing. That's a horizontal axis that are at one. Is it? No, from that
No, it's a max at 1.
side.
So we would keep increasing all the way up until 1, right?
Yeah.
Okay, so we have 1 point of inflection there. We have another point of inflection. Oh, I should have changed my concavity, sorry, it's 0.
So it decreases from
It
one.
doesn't decrease until,
One. It's one.
there we go.
And it's talking about.
I don't know how it exactly showed up, but there's a point of inflection there, there's a point of inflection there-ish, a relative max there-ish. Now it starts decreasing. What happens at 4?
Goes to that cycle has another.
Agree to four.
It decreases, and then it decreases slower, and then it levels off. That should be leveled off, sorry, it looks like it starts to increase, I apologize.
Doesn't have to be like exactly like, it can be translated down or up.
Exactly. So this entire thing that I just did, uh-oh. You guys know what I'm trying to do, right? I'm trying to group everything in my graph. So let me get rid of the examples. I don't want that to come, and I want you to come. Okay, there we go. This could be any, oh. Yes, I know.
Yes.
Here. This could be anywhere. Here. This could be anywhere as long as all the characteristics line up vertically, right? So this could have been down here, could have been down there, could have been way up here. What they're looking at is the increasing, decreasing, leveling off, points of inflection, that type of behavior. Does that make sense, guys? And P.S., my point of inflection is a little bit off, if you notice. Technically, the concavity should not have changed until here. So it would be concave down all that time. Then it would start to be concave up just for a little bit. And
Like, okay, so technically you're doing the antiderivative.
antiderivative, but I don't know plus C, which is why Noah was able to, or whoever said it, it's able to be translated, yes. That makes sense? Whew. Graph of derivative stuff. We got stuck a little bit, but then we powered through. Are we okay? So question, did you guys see any motion in homework?
Wait, on 5-2.
Wait, was that 5?
This is 5-2, right?
What?
We never did that.
We didn't do any of
Yeah, we didn't do anything.
Oh, no. It's okay. Review.
Rolls theorem. We never got to rolls theorem.
We were
I'm
here.
gonna erase all of that.
Well, rolls theorem.
Oh, wait, you were supposed to tell us.
Guess what? You're gonna see what we just did in section 5.3. Yay! All right, well, that was fun.
13.
We were supposed to go over the multiple choice.
Yeah, that's right. Well, it was fun. It's okay, I'll come steal him. He's a precursor. Look, he's an intro. Okay, change him to, ready? Change him to 5.3 intro. Go team.
What
Are we gonna write some rolls theorem? Write the rolls theorem, right?
I did that in, wait, I put one word on this.
You're okay. You're okay, because we did the multiple choice in the workspace. We did exploring mean value, antiderivative. You guys just did an intro to section 5.3, and we tied it into 5.2 because you guys are awesome. How did we tie it in?
We didn't.
The final sketch
It's an
is...
antiderivative.
Pause, the final sketch. I want you to label it antiderivative.
Oh, I didn't even do it.
You didn't even do it. You're a party pooper. Antiderivative. Graphically. We figured out an antiderivative, but we didn't know the plus C. So therefore, it could have been translated up or down. Yay, the end. Well, what?
We can write minus C, right?
Technically, but standard
This is calculus.
calculus notation is plus C because C can be a positive or a negative, so why write minus?
Just gonna be different.
We can add it, we can add it and negative.
Buzz, write down Rolle's theorem. Ready, set, go.
I will.
Did you need it for homework? No. Why was it after homework? Because it is just a special case.
Oh, wait, what's is it under 5.2?
We're still in 5.2. What? I was supposed to have the next. Oh, yeah. Hold on. Wait. You're okay. We were in 5.2. We put it together into 5.2. I said you can label this in your notes as intro to 5.3, which should have been in 5.2 all along, right? Now, do you really need to write a lot for rules? No. So Jason, theoretically, that nice little white space I see can be rules. But I know that you like making things nice and neat, so I don't know what's up to you. I'm sorry.
It's right in the middle.
Okay, see there you
My
go.
favorite.
Yeah, exactly.
It's right in the middle.
For those of you guys that are just writing a little bit, question, what is the key new characteristic if roles is really just a special MBT or a special application of MBT? What's special about it?
F prime is equals 0.
F prime is equals 0, which comes as a result of, there we go, the two new things. It's MBT, continuous differentiable, continuous on the closed, differentiable on the open. It's MBT, just the one special thing is that the heights at A and B are equal, and if the heights are equal, MBT would say, okay, cool, then that average slope I would replace, if they're equal, I could replace f of A with f of B. I end up with a slope of 0, which means I have to have a horizontal tangent somewhere.
Oh.
We didn't write it down yesterday, but we did talk about it. So, you're just writing down roles, f of A equals f of B, which means there has to be an f prime of C equals 0 in there somewhere. And with that, we are done. Whew, with section 5.2. Let's talk about these multiple choice in your workspace. Color pens out, spirals out. We're starting in our workspace, and then we're zooming to 5.2 grading. And we're zooming to 5.2 grading. But first in our workspace.
What kind of gun?
Yeah, I just did.
Oh, we already graded it.
We already just graded it?
We already graded it. It's supposed to go over why we missed stuff.
Alright, kiddos, what did we miss in the multiple choice yesterday? What did we need to go over?
56.
53?
We went over 56.
And 54.
Did we go over? I thought I
No,
just
you
answered.
went over, you just went over the answers.
Oh.
I thought you went over it.
I didn't finish one of them, but
Okay. Pause. We had somewhat of a question on 53. Raise your hand real fast. Okay, 53. Who wants to talk it out? Someone got it right. Katrina, go for it.
So, you have to use f of b minus f of a all over b minus a.
And why do I use these ones?
Because it's between 0 and pi over 3.
Good. And where am I putting this?
What?
Where am I putting the pi over 3 and the
Oh, you're
0?
plugging it into the original function f, so it's cosine of pi over 3 minus cosine of 0, pi over 3.
Pause. You guys might be tutoring AB kids someday soon. What do you think one of those common mistakes is, even if they know the MBT formula?
They switch 0 and pi over 3.
Maybe they switch the order, but there's something more. They plug it into negative sign because they think they need the derivative. It's more of the common mistakes. Hey. So, what is cosine of pi over 3? What's cosine of 0?
1.
So I have negative 1/2 all over pi over 3.
And then you multiply by 5.
Oh, that's like great.
And then you get 3 over 2 pi. Negative 3 over 2 pi.
Yes? Does anybody have a question or somewhat of a question on 54? Okay, who can talk it out?
I got it wrong.
Yeah, I got it wrong.
Who can talk it out? Okay, Noah.
Yeah, so I took the derivative,
Which was?
parentheses 3x squared minus of x close parentheses and the e to the power of x.
Okay, now what?
And I set that equal to 0, but I disregarded the e because well, e can never come out to be 0. So I just, since it's a multiplication, I just did the parentheses inside, set that equal to 0, factor out the 3, move the 4 to the other side, so x equals 0 and 4. Put that in a sign chart, at 0 and 4, I got plus minus plus.
That gives you the answer.
Yeah, okay.
Yeah.
Why didn't you have to drop down the x cubed, and then, and minus 6x plus 8, and then multiplied by, I was doing like G.
That's what I did.
But then what happened to the x cubed minus 6x plus 8?
That's the prime.
That's the prime, but don't you have to drop that down first?
No,
You're thinking logs.
Each of you times u
Do
prime.
you guys see what she was thinking? She was
Yes, I
thinking
was thinking
logarithms,
it's
bring the
two.
power down.
Yeah.
With exponential, just think, what's the derivative of e to the u?
I was doing a mixed
You were doing
power
it.
rule and, cheat rule.
Oh, very
Yeah, like every game.
Very good. So the best way to answer that question, kiddos, would have been, you need the derivative of e to the u, which is e to the u times u prime. Does that make sense? All right, who has at least a little bit of a question on 55?
Oh, no, I'm good.
No.
I was pretty angry.
Okay, how about 56? Okay. Who can explain to me 56?
Noah cat.
Noah can. Can anyone else?
I go.
Kind of make it so it's not super tiny. No one else? Just Noah? Go ahead, Noah. How do we do it?
Oh, first I took the derivative.
Of everybody? Probably in your head, but kind of.
Way too.
So he was thinking of cosine, he was thinking of
For 1, 2, for.
Wait, what number is that?
56, the last one. This one would be 3/5 x to the 2.
I mean,
No, sorry.
I didn't really write it out, but yeah, I did it in my head.
Yeah. I'm showing it written out just for Noah because he's going to say what's in his head.
Yeah.
And some of you guys might need to see it written out.
I didn't exactly do all of it. I just did like the fundamental things of each one. Like I disregarded the first two because they're all continuous on the intervals that they give you right now. But it also has to be continuous in the open interval of the derivative. And I knew that the first two sine and inverse sine, those you're fine for. Because the bottom will come up to 0. The C I knew because even if you minus it by 1 at the top, you wouldn't have a negative on the bottom. Yeah. So D, I knew that there would be
Sorry.
a.
These four are continuous. This one is continuous on the interval because his discontinuity is not on the interval. So they're all 5 continuous, that's what he was saying. So continuous is true, now he's looking at differential, does that make sense? No, you're good. I didn't explain myself, I'm sorry.
Like, first two graphs look fine. Third graph, I knew there wasn't a radical on the bottom, so it would never come out to be discontinuous. And the fourth one, I knew there was a radical on the bottom, and since there's a radical on the bottom, there would be a 0, because between -1 and 1 is a 0. So you put the 0 in, you get 3 minus square root 0, and there's 0 on the bottom. Number of results, discontinuous. And the last one, I kind of didn't even touch because there was a score on the bottom.
Did anybody get stuck on B, thinking like the plus or minus 1? You might not have gotten that far.
No, that's why not. It's open interval.
Differentiable only needs to be on the open interval. Continuous is on the closed interval. We can have sharp points at the end points, it doesn't matter. For MVT. So this one, it didn't work, but it does work on the open interval. So this one works no matter what. This one works no matter what, no denominator with an x. This one, x fails at 0. So right away, he is continuous, but he's not differentiable at 0. So that's why you could jump to D. That's why I know I didn't really even worry about this one, but this one did have problems, but it was at 2, which is not in the interval. And this one, the derivative did have problems, but not in the open interval. It was at the end points. Did you say a question? Did I answer for you guys?
Can you do MBT for sine?
Arc sine?
Yeah, can you like the actual MBT
It'd be messy. I mean, it'd only be easy to do if it was something like sine inverse of root 3 over 2. Or sine inverse of 1/2.
1 would be this pi over 2 minus negative. No, minus 3 pi over 2 minus.
Sine inverse goes positive pi over 2, negative, so it'd be negative pi over 2. Alright, kiddos, so it is a bit messy, that one. And there was theoretically a lot of math. Check continuity for all 5. Check differentiability for all 5. But if you noticed, he's always continuous, no sharp points, so he's fine. He'll be continuous and differentiable. This one you might not have known, so maybe you would have left him off. This one, I can plug anything in, take the derivative, there's still no denominators like Noah said. This one, I can plug anything in continuous, but as soon as I have a denominator, x can't be 0. Hopefully you would have gotten to D, even if you had disregarded A and B, and checked the easier ones. But I understand it was a little bit overwhelming, sine inverse got some of you guys stuck. Kiddos, here we go, section 5.3. Go ahead and put your pencil in your notes. Oh, you guys are in your spirals, sorry. Sorry. I was gonna have you open your spirals, but that doesn't really help. So the evens, we have number 10A and B. Uh-oh. No, we're on 5.2. Oh, you mean for chapter 5.
I know you put on it. I have been second lines. You don't. I do have some.
Slope is the average slope. F of B minus F of A over B minus A, and plug in a point for Y1 and X1.
That's a second line?
Yeah, it's in the purple line.
You just need a slope.
Oh.
Yeah, like a normal slope, not an instantaneous. Tangent line, when you take a derivative. Tangent line and derivative. Secant line, just do an old-fashioned Y2 minus Y1 over X2 minus X1, aka F of B minus F of A. Did you guys just disregard what I said yesterday? Remember notes? We talked about secant lines?
No.
No, we didn't talk about.
And I said to find the slope, you just do Y2 minus Y1 over X2 minus X1. And I said that MBT is secant line and tangent line slopes. You silly goofs.
I didn't know who the secant line was.
Cuts through the graph. Okay.
Oh.
So, of course, the best one is 1 over root 2 and 1 over root 2, or root 2 over root 2. Sorry, root 2 over 2, root 2 over 2. Decimal, all right, fine, but it shouldn't have been. B, you need to find your derivative, plug into your tangent line. Of course, this is good. Some of you might have simplified. No reason to get a decimal whatsoever. Unless you were checking with the book and saw they were decimals. Here's your 3 halves, and then your y was root 2 over 2, or 1 half. Sorry, 1 over root 2. If you distribute and simplify. Oh, wait. What's wrong? Remember, get the answer first. Get the answer, and then if we have time, check the steps. You had to solve for C, which was 3 halves. You had to plug in to find your F, and you already knew your F prime. So you have your x1, you plug in to find your y1, and you already knew your derivative. Number 12 and 20. You would have found your average rate of change to be 10.6. By the mean value theorem, the instantaneous rate has to equal that average rate for some place in between 0 to 20. No, rolls would be derivative equals 0, yeah. This is MBT, derivative equals a number. They told us the fact that the temperature was constant before 0. So we knew that the rate at 0 would have been 0. Wow, IBT. I don't know if I would have used that.
You could have used that. MBT makes no sense.
MBT makes no sense, yeah.
That's less words.
Because MBT, you just have to find the average and say, oh, since my temperature is continuous and differentiable, therefore, since the average is 10.6, then the temperature has to be 10.6. I don't know why these items would work.
Anything like in between, at some point it's going to have
It
that
has to be
average.
10.6.
Yeah, that would be MBT though. If they were asking about 10.4, that would make a little more sense, but 10.4 wouldn't exactly be 10.6, but, that's weird. I would just use MBT on that one.
320. The heck was an alien C point?
Wait, was that even the same?
That's what, see, Kyle agrees. There was no A, B, and C.
There wasn't first one? You weren't
I don't
thinking
think so.
about,
It says find local
Yep.
increasing ADs.
was it that function?
Yeah.
It was that
They
function.
use local extrema, we use increasing C as decreasing.
No, there's no extrema, it's always decreasing.
I think, like.
It's just answering each of the different pieces. It's asking the extrema, it's answering the increasing, it's answering the decreasing. And then 30 antiderivative and 34 antiderivative. Who's still grading? Let me see hands.
That's why there was no A. No.
Okay.
Oh my gosh, my words have failed me. Oh wait, I had a question on 34. Never mind.
Was it 1 over x minus 1?
Yeah, it was natural law.
1
I
over
was thinking I had to do like U sub or something, and I don't remember how to do U
Oh my
sub.
goodness, I forgot that.
Yeah, but your U prime is just 1, so the U wasn't an issue.
Yeah.
If it was an issue.
I don't remember how to do U sub.
Don't worry.
whatsoever.
We haven't gotten that developed yet. We haven't gotten that
I bet Lucy is there.
Is that the next
Is that right,
chapter?
Lucy?
involved.
Everybody do U sub?
Yeah.
Yeah, exactly. I knew you would.
Alright, everybody still grading? Okay.
Just like
Let's go ahead and get back to notes then. Oh, sorry, 38.
Oh, wait.
Go stand up, 38.
I don't need it, okay. I'm good, I got it.
Why
You guys
did
had
you
to find the C because you found that antiderivative and you had to plug in the clue. C is 3.
Oh, I got it wrong.
You guys mess up the sign?
do we have to solve for C?
Yeah, otherwise it wouldn't be totally done.
Wait, how did we solve?
It would make some sense.
Because they gave us the point, x and y, so you plug in x, plug in y, solve for C.
Thank you.
Alright. That was quite the ordeal.
Thank you.
Question, where does section 5.3 begin?
Connecting F prime and F double prime with the graph of F double.
Okay, that's the title, that's good. But where does it begin?
First derivative test.
First derivative test, second derivative test. Question, have we already reviewed? Yes, the first derivative test, second derivative test.
Yes.
Okay, so if I was to blank screen right now, you can write first derivative, second derivative test. First derivative test. Connecting f prime and f double prime with a graph of f double prime. Connecting f prime and f double prime with a graph of f double prime. Okay. Connecting f prime and f double prime with a graph of f double prime. Okay, the very first tools that we're going to think about are the first derivative tests and the second derivative test. The first derivative test and the second derivative test. Now, first of all, what are the first derivative and second derivative tests for? What are you finding?
Increasing.
Nope.
Maximum.
Relative extrema.
Relative
Concave
extrema.
up and concave.
So, when you write down first derivative test and second derivative test, you should write down parenthesis extrema, relative extrema. How can a first derivative tell us about relative extrema?
The slopes of the origin.
Critical numbers first, then sign changes of the slopes, aka sign chart.
Wait, what are we writing?
First derivative test for relative extrema. And how does, well, I'm having you guys summarize it without just using my words. Because you've done it with my words already this year. First derivative test, parenthesis, that's for relative extrema, aka how does the first derivative tell us about relative extrema? And we said we have to know two things. One, the critical numbers. And then two, the signs of the derivative or the signs of the slope, aka sign chart. First derivative test for relative extrema. We have to find critical numbers, and then we have to think about the signs of the slopes before and after, aka sign charts. Now what's the other test?
Second derivative test.
Once again, for relative extrema. It's not just concavity. A lot of you guys get these confused. There's a concavity test using the second derivative. But the second derivative test is for relative extrema.
Are you giving?
How can the second derivative tell us about relative extrema?
Are we giving F prime?
You can be given f or f prime.
So we need those
To write it twice now.
So critical numbers first. For the second derivative test, it starts, For second derivative tests, you still have to use critical numbers because only critical numbers are possible extrema. Only critical numbers are possible extrema. Sometimes a pip is a critical number also. But pips also can
So pips cannot be,
pips are not necessarily extrema.
okay.
There we go. Critical numbers are the candidates for extrema. So, second derivative test, pip, no. Second derivative test, critical numbers, blah, you guys got me all mixed up. Second derivative test, critical numbers. That's weird though, because we don't do critical numbers with the second derivative unless we're doing extrema.
Yeah.
So second derivative test for extrema, critical numbers, and then what do we do? Before and after? No, we don't necessarily even have before.
Plug in the second.
Plug in
Yeah.
and check the sign of second derivative, which tells us concavity of the original. Now, there's a lot more up here and a lot more details. But the first derivative test for relative extrema, critical numbers, aka check the domain first, but critical numbers, you have to see sign changes. You have to go before and after sign changes of f prime. Second derivative test, still critical numbers, taking into consideration the domain. Plugging those critical numbers into f double prime and checking the concavity. What if you plug in and a concavity is undefined? Second derivative test fails, go back to the first derivative test. Remember that from last year?
Yeah.
What's an example? Is there a concavity of an absolute value of x function? Nope. But is there a relative min?
Yes.
Can the second derivative tell me what this is? No. Can the first derivative?
Tells me
Yes.
there is.
Yes. Okay, you guys might be getting a couple more things down. But when talking about relative extrema, we can work from or work with the first derivative or the second derivative, but in very different ways. First derivative before and after critical numbers, the signs of f prime. Second derivative, plug in the critical numbers to f double prime, check the concavity if it has any. What else does the second derivative tell us about, guys? So, is the second derivative only about relative extrema? No. But can it be used for relative extrema? Yes. But for relative extrema, we think critical numbers. For concavity, we think pips. That is a common mistake. Second derivative has to use critical numbers for relative extrema, but it uses pips for concavity. Now, most of this is just Forever card stuff, right? So what do you think is the most dangerous part on this page?
An example.
The actual inflection point of graph thing. Yeah.
One of the most common mistakes in AB content, if they want you to find an actual inflection point, a lot of students forget that all pips need to be tested. All pips need to be tried. All pips need to be checked for whether or not the sign of F double prime changes. And all explanations, all justifications must say not only is this point a pip, is F double prime equal to 0 or DNE, and in the domain of F, but also there is a sign change of the second derivative. Possible, pitchfork second derivative. Actual must be a sign change. So the only actual inflection point of this hypothetical sign chart, second derivative sign chart that I plugged in, the only actual is B. But what were the pips? So we must test without testing. We could have made a grave error. And without stating a sign change, we could have missed a justification explanation point. Now, when I come down to the example, what are you guys going to be asked to do, or what are you going to need to do?
Derive twice.
Twice.
Derive twice.
Fine.
Can we do long division and just like simple?
We could try to see if x minus 2 divides out. We could do long division, or we could just say, hey, let's plug in 2 and see if it's 0 over 0, just to check before we do long division. So if we plug in 2, we have 8, 10, and we have minus 9. It's going to be 1 over 0. So it's a good idea to try to simplify. It's not going to simplify well. But just this steps. You guys, I know you don't need me to practice the quotient rule with you, but you would find y prime, simplify. Find y double prime, simplify. Simplify in a way where you can set the numerator equal to 0, denominator equal to 0. But question, what do we need to look out for? What was our domain from the beginning? So, can there be an inflection point at 2?
No.
No, be careful, because there might be a sign change, but you have to say there's not an inflection point if it doesn't exist there at the beginning. So you find the first derivative, find the second derivative, pitchfork the second derivative. We are doing pips, we are doing concavity, so we're not looking at the critical numbers, we're looking at the zeros and to find the second derivative. Then what are you going to do? This, then?
Centric.
Good.
Whoa, what happened?
It's been freaking out. See, it's just getting worse. You're going to look for a sign change, true? You don't even technically need to talk about or answer the bottom, you're just looking to the top. Okay, those are inflection points. We've talked about first derivative test, second derivative test, relative extrema. We've talked about concavity and points of inflection. Okay, what was this page that I thought we'd already done?
Graph clues.
Graph clues. Okay. How much time do we actually have?
Like 1 minute or 30 seconds, depending
Okay.
on the perception.
Oh my gosh, you're right.
Let's not worry so much about the graph clues. Let's instead do an example. The graph clues will come back tomorrow. We'll brainstorm and see if we can come up with as good or even better clues than they did last year. But question. What's going on with this one?
Position?
Do you see how the relationship between an original and a derivative and a second derivative is going to be applied in motion? And it's not just applied in finding the first derivative, finding the second derivative. That's easy, but where do they catch you? Basically describe the motion. What do you think they're talking about?
If it's like speeding up or slowing down.
Left and right and speeding up and slowing down. We want to make sure you guys are decent.
Oh, we got this, Kyle. We got this.
Homework is due tomorrow, but we will brainstorm after you do homework as far as the graph clue. Better list than last year.
You just type it in the group. You just type your name. Yes. I need a because like everyone. Yeah. But we have to also add Jaden later. When Jaden gets in here, Jaden, you should join our group chat.
Grade 5
On what?
brainstorm on
Dead.
how we would do that.
It's really just a chat where we ask who has golf homework now.
And start.
It used to be a bunch of spam memes. That was last year when we created.
You guys can grade with the video.
Have fun. Because of that English project.